question, question number 6. Again, a very good question. So this question says there are two particles A and B. They start from the same point and move in the positive x direction. Okay, so they are starting from the same point. Okay, they are starting from the same point. So let's say this is A, let's say this is B. They are starting from the same point. In the time interval 2 seconds after they start, their velocities v vary with time as shown in the following figures. What is the maximum separation between the particles during this interval? All right, guys, so we have been given the velocity of A in the form of a graph. We have been given the velocity of B in the form of a graph. We have to figure out what is the maximum distance between these two particles. So what will I do? I will, put this graph on the same, I will superimpose this graph. So let me shift this graph here. Fortunately, the scales are same. The time scale, in time scale, one block represents 0.5 seconds. And on the vertical side, one block represents 1 meter per second. Same is happening in this graph also. So the scales are same. So we can simply shift the graph. So if I draw this graph, it would be like this and it would be like this. So pay attention there. So the yellow color represents the graph for particle B, and let me mark the graph of A in red color. So the red color represents the graph of A. Okay. Now guys, can I say that so long as the speed of A is more than the speed of B, A will keep on gaining, it will keep on becoming farther and farther from B. So A is moving at a higher speed, B is traveling at a slower speed. So this gap will keep on increasing so long as the speed of A is more than the speed of B. And this happens during this entire 1 second duration. After that, the speed of A drops, the speed of B also drops. Okay, here, after 1 second, momentarily their speed became equal. But after then, again A got a higher speed. So again, the distance between A and B will keep on increasing until this time. At this time, A and B, they acquire the same speed. Rather, after this time, B becomes the faster car. So B will start gaining on A. All right. So until this moment, until this time, which is 1.5 seconds, until this time, A was increasing its distance from B. A was definitely ahead of B, but not only it was ahead, it was increasing its distance with B. After 1.5 seconds, the distance between A and B will begin to decrease. So the distance between A and B at time 1.5 would be the maximum separation between them. And how do we calculate that? So guys, area under the curve gives the displacement. So I can say that the difference in area will indicate. So for example, the area under the yellow curve is this one during the first second, and the area under the red curve, is this one. Okay, so the difference of area is this. So this is the distance gained by A in the first second. Similarly, this would be the distance gained by A in the next half second. So how much is this area? I think that's pretty easy for you to calculate. The height is 2, this is 1, and it's a triangle. So half into 2 into 1. So this area, and then how much is this area? Again, it's a triangle. So half into, now this height is 1, okay, and this width is 0.5. Okay, so this becomes what? 1 plus, and this is 0.25. So this is 1.25 meter per second. So that is the answer. All right. Not meter per second, I'm sorry, 1.25 meter. So B option would be the answer. This is the maximum separation between the two particles. B option. All right, getting this everyone? Okay, nice, good question. Okay, now the next question says a material particle is chasing another one and both of them are moving. So material particle, why did the question, in many questions of this book, material particle word has been used. Why? Material particle basically means that something, matter is moving, which basically rules out the cases of infinite acceleration and infinite velocities. Okay, so material particle means that you have to rule out any possibility that involves infinite acceleration or infinite velocities. Okay, anything that has mass, it cannot change its location in negligible time, because that would indicate an infinite velocity, which is not possible. Okay, and similarly, infinite accelerations are not possible because that would require infinite amount of force. Okay, so material particle is chasing another one. Not that this information was relevant in this question, I just noticed it, so I thought of highlighting it. Okay, another one, both of them are moving on the same straight line after they pass a particular point. So basically, let's say this is the point after which the particle becomes visible to us. Before this something was happening, but we are not aware of this. After this the particle will travel towards this side, and then the particle will become visible. So let's say this is first particle, this is second particle. So the first particle, when the first particle appears here, we start our clock. So that's t equal to 0. As soon as the first particle appears, we start our watch, and we notice that it increases its speed from 0. It starts increasing its speed from 0, and this is the graph. Okay, so if I have to write the acceleration, let's say this value is some value which we don't know, let's call it as v1. Okay, rather v0, because we are using one subscript for one of the particles. Okay, so the acceleration of the first particle will be written as v0 divided by the time taken, which is 4. So this is the acceleration of the first particle. Okay, similarly, if I think about the second particle appeared here at 3 seconds. By that time the first particle already traveled some distance, so the second particle appears at time 3 seconds, and it also appears with a zero velocity. And then the velocity increases. Okay, and the velocity becomes v0 in the next 1 second. So the acceleration of the second particle, we know, would be v0 by 1. Okay, which basically tells us the ratio of the acceleration. Like for example, we can write that a2 is equal to 4 times of a1. So this graph gives us several information, one of which is the ratio of the acceleration. It also tells us that at this particular location both had zero velocities, although they arrived at this location at different instants, but they had zero velocities. Now let's say at time t they catch each other. Like, okay, so at time t, if they catch each other, then by that time this particle would have covered a distance of half a1 t square. Notice this initial velocity was 0. Alright, and if this particle has traveled for a time of t seconds, then this particle would have traveled for a time t minus 3 seconds. So this distance, the same distance, can be written as half a2 t minus 3 square. So we need to equate these two. Equating these two will give us the value of t. So let's do that. So we will write half a1 t square is equals to half a2 t minus 3 square. And then a2 can be replaced by 4a1. Okay, so rest is math. Rest is pretty simple math. I am pretty sure you can do this. Okay, so the a1 gets cancelled, half gets cancelled, so we are left with t is equals to 2 times of 3 minus t. You can also mathematically correct thing would be to also consider the possibility of a negative this value, because we are taking square root on both sides. So mathematically the correct thing would be to do this. This part gives us what? This part gives us t as 6 seconds, and this part gives us 3t is equals to 6. So t as 2 seconds. Because this is less than 3 seconds, so we discard this value. So we take this as the answer. So t equal to 6 seconds will be the answer to this question, as we can see here. Alright students, okay. So that is question number 7. Now question number 8. Okay, this is a very good question, guys. This is a very good question. So question says that there are two cars A and B. They simultaneously start a race. Velocity of car A varies with time t according to the graph shown in the figure. It acquires velocity 50 meter per second few seconds, this is important, few seconds before 100 seconds. Okay, so few means definitely more than one, right? Definitely more than one. And thereafter moves with this speed. Car B runs together with car A till both acquire a velocity of 20 meter per second. After this, car B moves, this is again important, car B moves with zero acceleration for 1 second, and then follows the velocity time profile identical to that of A with a delay of 1 second. In this way, car B acquires the velocity of 50 meter per second 1 second after. All right, so this few and this 1 second after. Okay, this is important. How much more distance delta S the car A has covered? So guys, what does the question says? This is the graph of A. This is the graph of car A. So let me redraw it. It acquires a velocity of 100. So it probably acquires 100 somewhere here. Okay, and then this is a few seconds. Okay, so this is a few. That means it is more than one. Okay, this is few seconds. Okay, very poor handwriting. Let me improve upon that. Okay, so this is few seconds. Okay, now what does the question says? B car starts with A and it follows the trajectory of A till the speed was 20. Okay, then it runs with zero acceleration for 1 second. Okay, so this gap should indicate 1 second. I should make it a bit smaller. Okay, why I should make it a bit smaller? Because if this length represents a few seconds, then a similar length should not represent 1 second. Lesser length should represent 1 second. Okay, and after this, the same profile is obeyed. So you have to just shift this graph. Okay, imagine this. Make a copy graph and start drawing it from here. So when you do that, you will probably end with a graph like this. And what is this gap? This is 1 second. Okay, this is 1 second. Are you getting this? The question says that it requires the speed of 100 meter per second 1 second after A. Okay, and then so at this point both of them have acquired the same speed. All right, so after this they are moving with maintaining the distance between them, whatever the distance between them is, because they have both acquired the speed of 100. Okay, they both acquired the speed of 100, so they are moving with the maintaining the same distance between them. Now we have to tell how much is car A ahead of car B. Okay, and if you look at the options, it's 30 meter, less than 30 meter, 20 meter, insufficient information. So you know, since less than 30 is mentioned, we have to be very accurate. Like anything less than 30 will make that option correct. Okay, so if I ask you what is the distance covered by car A, what is the distance covered by car A in 100 seconds? So that would be the area under this curve. Okay, what is the distance covered by car B? Again, area under the red curve. So what is the difference? This area is the difference. So this would be the distance between car A and car B. Are you getting this? And also keep this in mind that this length is 1, this is 1. So any horizontal line that you draw between these curves, that is 1 centimeter, that is 1, this is 1, this is again 1, 1, 1. Okay, so all this is 1. So we have to calculate this area. Okay, so if the question boils down to calculating this area, all right, the ultimate question is this. Let us draw axis like this, you know, for the sake of you know, doing calculations which in which we are familiar. Rather, you can draw it from here. Okay, this is your x-axis. Okay. So what we are now suggesting is that, let's say this is a coordinate system where this is y-axis, this is x-axis. This would be a curve, let's say y1. This would be a curve, let's say y2. Okay, and at any x, okay, at any x, if I consider a strip of width dx, then this area dA, how will we write this area? This area would be y2 minus y1 into dx, and y2 minus y1 is always 1. Okay, it's always 1 second. So multiply it with dx. So integrate to get this area is integration of dx. Okay, so this means that the area that we are looking for, this area, okay, is integration of dx as x changes from this value to this value, right? So this difference is what? 30. So you can say that you can write 0 to 30 also, you can write 20 to 30, 50 also. So basically the area is 30 meter. Alright students, so A option would be the correct one. Got this everyone? Okay, 30 meter is the answer. Okay, now we'll go to the next question, which is question number 9. Okay, this question says a model rocket fired from the ground ascends with a constant upward acceleration. A small bolt is dropped from the rocket 1 second after the firing, and the fuel of the rocket is finished 4 seconds after the bolt is dropped. Airtime of the bolt is 2 seconds. Acceleration of the free fall is 10. Which of the following? Okay, so let's first solve the question. Okay, like we'll check the options later on. So a rocket started from this point. Let's say it started with an acceleration a. I'm considering rocket as a point particle. So after 1 second, it drops a bolt. So after 1 second, the rocket would have covered a distance of half a1 square, half at square, and by this time the speed of the rocket would have been a into 1. So this would have been the speed. Now the bolt is dropped here. So the bolt has the initial velocity of a. It is at a height of a by 2. It will go up and come down and hit the earth. So this entire journey, okay, this is the airtime of the bolt, and this airtime of the bolt is given to be how much? 2 seconds. This airtime of the bolt is given to be 2 seconds. So what equation can I frame for this journey? Considering upward as positive, I will write initial velocity as plus a. This is initial velocity. Time is given to us as 2 seconds plus half. Acceleration is in downward direction because it will fall with a acceleration of g. So minus 10 because it is in downward direction into 2 square is equals to the displacement. The displacement is in downward direction, so we will write it as minus a by 2. This length is a by 2, so displacement is minus a by 2. So we will solve this equation. So this equation will give us 5 by 2a is equals to, I have taken this on the other side, this becomes what? This becomes 20. Okay, this becomes 20. So a becomes equals to 8 meter per second square. Once you have the value of a, everything else can be easily calculated. For example, now we know that this height was how much? This height 4 meters. Speed was how much? This was 8 meter per second. Also, not only this, the question says that we know the acceleration of the rocket. The question says that the fuel of the rocket was finished 4 seconds. So when the rocket was going up, after 4 seconds, if its fuel is finished, then what is the height of the rocket when the fuel is finished? That height would be half into acceleration into 4 square. Check this acceleration. Oh, 4 seconds after the bolt is dropped. So the total time would become 5. The total time would become 5. Okay. So 5 is square. So how much is this? This is 100 meters. So at the time when the fuel was finished, the height of the rocket was 100 meters. What was the speed of the rocket? The speed of the rocket would be a into t. A is 8, t is 5. So it would be 40 meter per second. So after this, what will happen? Since the fuel is finished, now engine is not working, so the rocket is under free fall. So the rocket will up and hit the ground. So after this time, how much more time will it take to hit the ground? So again, we can calculate it as 40 into t, okay, plus half minus 10 into t square is equals to minus 100. On solving this equation, you will get the value of t as 10 and minus 2. You will discard the negative value. So 10 seconds is the time of flight of rocket after the fuel is finished, and the fuel was finished after 5 seconds of launch. So the total time in which the rocket was airborne was 15 seconds. So let's read the options now. Acceleration of the rocket was 8 meter per second square. This is correct. Fuel of the rocket was finished at a height of 100 meter above the ground. This is also correct. Maximum speed of the rocket during its upward flight. So maximum speed would be at this point till the time its engine was working, it was accelerating, and after that, because the acceleration was downward, so the speed will begin to decrease. So the maximum speed of the rocket during its upward flight. So it clearly mentions the upward flight. That is a good thing, because here the speed was 40. As it comes down, the speed of 40 would be attained here, and then as it travels further below, the speed will become more than 40. So we are not saying that the rocket never acquired a speed of more than 40. It did during its fall, but the question says maximum speed of the rocket during its upward flight is 40. So yeah, this is correct. Okay, the total air time of the rocket is 15 seconds. Again, this is also correct. So all 4 options are correct in this. All right, so all 4 options A, B, C, D, they are all correct. Okay, now this question is actually a question from terminal velocity. It is given in the kinematics chapter, but it is actually a question of terminal velocity. So it says that the drag force of a fluid of a body, drag force of a fluid on a body is proportional to the velocity of the body relative to the fluid. Student drops several identical stones from different height. So guys, here the thing is pretty simple. See, when a stone moves in a liquid, okay, if mg is more than buoyant force, which is usually the case, okay, then it starts accelerating downward. As it accelerates downward, a viscous force develops, and then it acquires a terminal velocity when mg becomes equals to the buoyant force plus the viscous force. Okay, so at this point of time, the stone starts traveling with a constant velocity. Okay, so if the speed is less than terminal velocity, then we can expect the speed to increase and become equal to the terminal velocity. If the stone enters the liquid with a speed which is more than terminal velocity, in that case what will happen, the drag force will become more, and therefore the speed will begin to decrease until the terminal velocity is attained. So this kind of graph will appear when the speed with which stone enters the liquid is more than the terminal velocity. Okay, let's read the option. So it says that the first graph is for a stone dropped from a small height. See, if we are dropping the stone from a small height, then by the time it enters the fluid, it will not have sufficient speed. Okay, so in this case, after the stone enters the fluid, it will then increase its velocity to acquire the terminal velocity. So this would be the graph for small height. This would be the graph for large height, because when it is falling from a large height, it would already be moving at a good speed, more than terminal velocity when it enters the liquid, and therefore the speed will decrease. Okay, and this would be the case when it acquires just equal to the terminal velocity as it enters the liquid. So the moment it enters the liquid, forces are already balanced, so no change in speed is taking place. So this is the case when the height is just good enough so that the particle acquires the terminal speed as it enters the liquid. So the first graph is for a stone dropped from a small height. No, that is wrong. We have figured out that the first graph is from a large height. The first graph is for a stone dropped from a large height, and the second is from a small height. So this is correct. Okay, the third graph is for a stone dropped from a height sufficient to acquire the speed v0 so this is also correct. Third graph is not possible. No, that's not correct. It is possible. So option B and C are the correct ones for this question. All right, got this everyone?